Good afternoon, everybody. Welcome to this webinar on about careers of people who've gone on from studying chemical engineering. We're just going to wait for the attendees to join. People are just dialing in and connecting to the webinar. So just bear with us for a moment and we'll make a start. All right, it looks like everyone who has signed in has joined the webinar. So we'll make a start. So good afternoon, everyone. Welcome to this webinar. My name is Cameron Yunus. I'm an associate professor at the Department of Chemical Engineering and Biotechnology. We're here to run a webinar today about what sort of careers you can have in chemical engineering after you graduate. So we're very lucky to have Rachel Cook here, who's one of our alums. She studied at Cambridge in chemical engineering, and she'll be telling you a little bit about her journey after she graduated and the types of things she's been involved in since graduating in chemical engineering. Rachel currently works for Amazon, and she's one of the global directors there. And she's really kindly taken out some time to join us today to tell us a little about herself. So without any further ado, I'm going to pass over to Rachel. Thank you.
Thank you. Yes, thank you for the nice introduction, Cameron. So I'm just going to share my screen here and take you a little bit through my career and what I did at Cambridge, and then what you can do after you've had a degree from Cambridge in chemical engineering. So I'm currently with Amazon, and I'm the global director of the reliability and maintenance engineering team. And that is not something I ever dreamed would be possible, perhaps even 10 years ago. So let's take a look at how I got there. So first, I can't see my screen anymore. Has the slide moved?
Yeah, I can see your screen. And it's moved on to your slide about your A-levels.
Great, thank you, Cameron. Zoom has decided to minimize. So yes, so I did A-levels in maths, further maths, physics, chemistry, and general studies. And I took an AS level in electronics at the same time as my GCSEs, because that was actually less work than doing GCSE electronics. I went to Cambridge, to Trinity College, took the natural sciences route, although I'm very excited about the new direct entry route to chemical engineering. And I also stayed for 7 years, and after my bachelor's, stayed to do the master's and then to do the PhD. I chose chemical engineering because I'm from the northeast of England. I grew up near Teesside and Wilton, both very large chemical complexes even today. And I was just absolutely fascinated by what was going on in there. And, you know, it just seemed like a massive experiment to play with, really. So that's a little bit about how I started off. I then did work experience very much in the oil and gas industry, petrochemicals. So started with ICI, which no longer exists, then did a summer placement with ExxonMobil on an oil refinery. And then my PhD was sponsored by Schlumberger, who are an oil field services company. So my career started off very much oil and gas, petrochemicals focused. And I think my perhaps advice now would be to think about which companies are actually going to be growing and really important in the next 20 years. Although you can always change your mind. So after I did my time at Cambridge, just a little summary of what we're going to go into some more detail of. I went and worked for Cadbury for the first 10 years of my career, actually. So I love chocolate. Things didn't work out with oil and gas companies. There was a bit of a downturn, a hiring freeze, and I pivoted to chocolate. And I absolutely love my time learning how all the different sweets were made and working for Cadbury. But Cadbury was then taken over by Kraft, which became Mondelez now, if you're looking for it. and I decided to leave and join SAB Miller, who were the world's second largest brewer. But they also were taken over by AB InBev after I was there for just 4 years. And so that's when I actually moved on to Amazon. But I had a lot of fun learning about brewing, getting to explore a little bit more of the world in that company. And I'll tell you and show you some pictures of what I got up to. I also do a lot of voluntary works and science outreach, which is probably why I'm here talking to you today. And one of the things I'm very proud of is being one of the founding directors of the Cheltenham Science Group. And also, I've done a lot of work with the Institution of Chemical Engineers, who do accredit the Cambridge degree. And I went from being a student member to being a chartered member. As you can see, I'm a chartered engineer. And then I became a fellow of the Institute of Chemical Engineers as well, and chaired various of their subcommittees and sat on their UK board. And even today, I still judge their global awards. So I think the first thing to sort of say is start with your why. What is it that you want to do in life? What's your purpose? And for me, like I said earlier, it was all about exploring these chemical plants. But that might not be for you. And as for me, it kind of changed to exploring chocolate. And now actually it's really just about doing and achieving things at a huge, huge scale with technological advances. And also, you don't know where your career is going to take you. So I made a various number of decisions, and they ended up with me meeting Simon Sinek, the author of Start With Why and Leaders Each Last, and many Infinite Game, many other great books and TED Talks. So if you haven't watched his TED Talks, I suggest you do. And literally, I made a whole series of choices that led to me meeting him on my very first ever trip to America. And that's kind of what I want to touch on is when you're, it's hard to imagine what a career can look like. Particularly when I was starting out, I had no idea what a career was. I thought, let's just start with a graduate program. But now I very much see as my career as a series of choices that I've made, and each choice is a different branch on this tree. And I've got so far, and then I've got a whole host of options still open to me, dependent on the next choices that I make, which is kind of exciting way to look at it. So we started with, these were the companies I'd done work experience with or summer programs with. And in the end, I was left with two really interesting job offers. One from Unilever to go and work in their frozen foods business, and the other from Cadbury to go and work in their confectionery business. And like many of those choices on that previous graph, I don't know what would have happened if I'd chosen Unilever. For sure, I would have lived in different cities, traveled to different places, and probably wouldn't be working for Amazon now. But Cadbury resonated with me with the culture and values. Really like the geographic locations. Don't underestimate the importance of that. So there's quite a lot to be said for being flexible in where you're going to live. That certainly opens up more opportunities. I've lived in 5 different countries. I'm currently talking to you from Luxembourg, where I've lived for the last 6.5 years. And actually last year I became a joint Luxembourgish British citizen. So opening up even more doors to me and shortcuts at passport keys. But also think of the remuneration and the lifestyle, right? So if you want to earn lots of money, you can go and work where nobody else really wants to go and live. That's kind of how it works. So think about where you are and what balance is right for you. So I started off as a Cadbury, doing something not really related to chemical engineering. I guess it was materials movement. And I working in the original, not the original, the second Fry's factory down in Somerset in the UK on a computer implementation. I very quickly expressed my desire to go and live abroad. Went to Dublin, where I started the production of flake praline, which was a fabulous product. Imagine a flake with lovely noisette, nutty praline around it, and then coated in chocolate-covered nuts. But that was an interesting experience for me to live in Ireland. It's a different country. It has different laws, has different currency, but you can get by in English. So that was my first trip living abroad in Dublin. After that, I went back to do some proper chemical engineering, as we might call it, and made Cadbury Dairy Milk with cream egg. And this is a bowl of fondant, this white liquid. It's white from the sugar crystals. And we've made it in this batch cooker, and we're in Poland now. This was my first ever trip to Poland, but definitely not my last. And we had to decide whether you should put the yellow in first or the white in first. And actually, you make these chocolate bars upside down. So for it to come out looking like the picture, you should put the yellow in first. But actually, because the yellow was smaller, it was better to put it in last. And so we had to make some various compromises and decisions like that. I then decided to learn a little bit about the cost inputs to the business and went and bought fruit and nuts for Cadbury's in the UK. And that was exciting because we also at that time did fruit and nuts for M&S. So a lot of the chocolate coated strawberries and so on, I also had to buy the strawberries. So that taught me a whole new skill set, which is still used to this day, and was a very useful part of the graduate scheme. Then I came off the graduate scheme and got my first job that didn't have a deadline to it. And I was a process development manager. And I was basically developing the new processes to make Maynard's wine gums light. So if you think of the health conscious Maynard's wine gums eater, we took out the sugar, half the sugar, and replaced it with polyols. And polyols are much harder to handle than sugar. They convey differently, and that presented a whole load of material handling challenges that I was able to overcome, partly with the knowledge from my degree. After that, here's a close-up of Maynard's wine gums being made in starch molds to absorb the moisture as they're being cooked, which is completely different to chocolate, where you're just playing with temperature. Here you're playing with moisture too. Really good heat and mass transfer challenges. And then I went to Poland. I managed to express an interest to go to Poland. So I said I wanted to go. And I got to play an important part in our largest ever investment at the time, which was building this chewing gum factory now on an old Soviet warfield. And this was really the first time I got a little bit more involved in construction, in civil engineering, as well as a little bit of mechanical engineering and packing machines. And really seeing, you get involved in everything from the car park layout to the boiler to the liquids and flavors storage to obviously making of the product. So again, we're handling polyols, but we've got a bit more roof height because it's a more modern building, and making various different aspects of making this product here, which is tropical twist. And again, this is related to chemical engineering and rheology because it comes out of the mixer. And it looks a bit like this, and then you've got to get it into those nice thin little chewing gum pieces that you buy. But as you do that, you're kind of manipulating the carbohydrate chains, and then they start to get forces on them, and they start to want to expand and contract, and you've got to do it carefully so that it holds the shape in the end. And I really, truly, this is me here. This is another thing I want to advise you to do. Think about what you're going to have to wear at work. It turns out I didn't mind wearing whites all day, having my hair up and not wearing jewelry, but it was a bit of a surprise to me. And I'm much happier now I have a job where I can express my true self. So that is, but very multicultural team, from Polish to Dutch to Argentinian, and we were timing with that stopwatch how long it took to make the chewing gum. And then this is the factory we were just in. Cadbury decided to build a chocolate factory right next door. And this is when I could really see the infrastructure of how you build a factory. And I got to work on some iconic products that I had grown up absolutely loving. So Fry's Turkish Delight. I always remember a very interesting call about getting the right color pink as we move to natural colors and flavorings. So the natural color pink was a very difficult one to achieve, particularly to make it look vibrant and pink against that dark chocolate background. They're also looking at fudge and curly whirly, two great projects from my childhood, and double decker and picnic. And similar to chewing gum, double decker has perhaps even more challenges because it all depends on the amount of air you've got in the nougat. And as you change the pressure and the temperature, the size of the nougat changes, but you've got to get it right because it's got to fit through the wrapping machine. And that's an awful lot of double deckers that you can get wrong. So that was a really great project, and I thoroughly enjoyed my 3 years in Poland. I learned to speak Polish and made many lifelong friends. But it was time for it to come to an end, and I moved to London. This was again, I wanted to live in London. I'd never lived in London. And I did a role at the interface between new product development, so marketing, and supply chain. So looking at new products and where we would make them, which was very interesting. And we launched all these different products. Probably none of them still around. Maybe Cadbury Eclairs is around in that particular packaging. But for me, it was 2012, and Cadbury was a sponsor of the Olympic Games in London, where I was now living. So I got to volunteer and sell Cadbury ice cream on the Olympic Park and go to a whole load of events, in particular this Paralympic cycling, where I met the gold medal winner from Australia. So not really something you can put on your CV, not something that you can ever plan to do, but it truly was a very memorable experience to be so involved in the Paralympics and to see behind the scenes how such an event is put on and organized. I also want to say I did a lot of volunteering. I actually started during my PhD at Cambridge, volunteering for an after-school science club. And then I also went on to found Cambridge Hands-on Science, which led to me keeping on going. And it's just to give you an idea that you can make choices with what you do with your spare time. So I took people around, children around the chocolate factory at Cadbury's, and we did various projects on breaking of chocolate bars. I did a lot of work with the Institution of Chemical Engineers. As a professional speaker, I went to the House of Lords. I won the IChemie's Young Engineer of the Year award for that. And then finally, I like this picture. I don't know if you can see my cursor, but I'm in a navy blue dress. I'm now giving awards. So as the chairman of the IChemie Food and Drink Special Interest Group, I went to Cambridge. We held an event in the department and I awarded the prize winner. So a whole host of new and different experiences that chemical engineering opens up to you, particularly if you work in a product that everyone likes as much as chocolate. But as I said, I decided to leave Cadbury and I joined SAB Miller, who I'd never heard of really, but they were on my list of companies I wanted to work for and hadn't got around to researching. And I got contacted on LinkedIn. So I encourage you to start now with a LinkedIn profile, keep adding contacts because that will make you more searchable. And one day it can lead you to finding a dream job. So I got to work with great brands like, I guess, the most famous in Europe is in England is Peroni, but Batiskia, Miller, Grolsch, Coors Light, and niche artisan beers like St. Stephanus from Belgium. And I was a manufacturing development manager. It was a global role, and this was the chance for me to go and travel the world. So I took both the photos on this slide. Bottom left, this is the oldest brewery in Africa. It's in Cape Town. That is Table Mountain. It's Newlands Brewery. And I was there to help them improve their brewing processes. And then right next to it is Fort Worth in Dallas, America. And this is a Miller brewery. And that was taken on my first trip to America. So I finally getting to travel the world. I also started to look a little bit about lean. So this is a little bit about brewing now. So we're going to Timisoara in Romania, starting to learn about world-class manufacturing and fishbone diagrams, some things from the degree, brewing curves. So starting to do a little bit of chemical engineering and a little bit of manufacturing and bring it all together. And just some more photos, you've got tanks, you've got pipes, you've got heat and mass transfer, and lots of really good chemical engineering in food and drink production. I also, it was also SAB Miller, having started in South Africa, was very big in Africa. So I actually got to go to Africa as opposed to just South Africa. So this picture on the top left of this bottling line is in Nigeria. The plane, the company plane that I flew around Africa in, again, can't really put that on the on the CV, but honestly, a very memorable experience. That's in Lagos as we're filling up with fuel. This is Accra in Ghana with the sun setting on on the brewery. So the pink is the sunset, and then at the bottom is Onitsha in Nigeria, which is a brewery on the banks of the Niger River. So really unique experiences, not necessarily holiday destinations, but I'm really glad I got to go there and meet so many different and interesting people, as well as continue learning more about chemical engineering. But then I decided to join Amazon. Again, I was contacted on LinkedIn. And I knew that SAB Miller was being taken over. The headquarters was being moved from the UK to America. So again, when you're looking at which company to work for, think about where is it headquartered? Because if it's headquartered in a country you want to live in, then that's a very good sign. And also think about the language of the leadership. So obviously it's SAB Miller, South African company, headquartered in London. English was the language. AB InBev, although it was headquartered in America, it was originally a Brazilian company, and at the higher levels, Portuguese or Brazilian Portuguese was the main language. So you could be excluded if you didn't learn those to a very high standard. So think about those things. They're not so important at the lower levels, but as you start to get higher up, it is, I think, important to be able to speak the language that the decisions and conversations are going on in. So I joined Amazon, complete surprise. I mean, I'd always shopped on Amazon, bought a lot of books from Amazon. And due to my experience in building those chewing gum and chocolate factories, I was in the team building the new warehouses or fulfillment centers, as Amazon calls them. And this is a photo in Manchester 3, with my team, and obviously getting to work with robotics and sorters. And I did that sort of central role coordinating how we funded and standardized our growth throughout Europe for probably nearly 3 years. And then I moved into reliability and maintenance engineering, which wasn't something I'd learned a lot about. I knew a bit from my time at Cadbury and SAB Miller, but I've learned an awful lot in the last 3.5 years. And I gradually expanded my scope until I led all of the European Central team. Then I was promoted to director in April 2022. And then since January, I've been the global director of the Reliability and Maintenance Engineering Central team. Now, I'm not going to say there's no chemical engineering, because there actually is. We have HVAC units, so heating, ventilation, and air conditioning units on all our facilities. We also have solar panels, which you can see this is a photo from, I think this is Spain. Very good place to go on the roof and have a look at the solar panels. Also, we have refrigeration and freezers from our food business. So there is definitely chemical engineering there, but there's also a lot more mechanical engineering. As you can see, these spiral conveyors. Safety is very important, which is why I'm wearing a t-shirt saying safety lasts a lifetime. And then again, we're starting to get more digital, looking at the Internet of Things. And that's something I've really been able to drive Industry 4.0 through my career at Amazon, and something where we're doing a lot of work in that area. And this photo shows all the equipment that my team actually build the software for as well. And that really is a little bit about my career to date. I know there's the opportunity for questions, but I'm now going to hand it over to Cameron.
Thank you so much, Rachel, for this really, really interesting talk. I'm quite jealous. You've traveled a lot. You've done a lot. You know, it's impressive. It's very, very impressive. And I still remember when I first came and joined the department, you were just finishing your PhD at the time. You know, it's over the 20 years what you've achieved is amazing. It's fantastic. We've had quite a few questions come through in the Q&A. I'm just going to go work my way through them. So first question from one of the students was, what exactly did you do in your job at Cadbury's? What department did you fall under?
So I fell under manufacturing for the most part. I don't know what what departments they're called now, but it was manufacturing, which is why I was an operations manager. And then they had a little R&D department, which we worked with, but I was always very much, and this is perhaps why I didn't stay in academia, but very much on the practical implementation of what I'd done. So that's the answer to that one.
In fact, I mean, one of the things it's just sort of a sidetrack, you know, and you probably were helping out right at the beginning with the Sutton Trust when we were first setting it up. We actually do a 5-day residential with students during August, where they learn about the science of chocolate and the importance of chemical engineering and that. So yeah, so it's a very important discipline in the food industry, you know. So another question, from your experience in the food and chemical industry, do you believe that a career focused on making food more chemically addictive, appealing to consumers is in demand in major companies?
I think there's a focus right now on healthy eating, right? But I think you've got to understand that all food is chemicals, right? They're processed to different degrees. Some are more naturally occurring, you know, and some are created through chemical reactions. In terms of the addiction of food, you know, the best things are sort of fat and sugar and salt, right? Which are the things you put when you bake at home, right? And that actually makes very, very moreish food. So I don't think the food and drink industry is really focused at all on making their products more addictive. I think the focus is very much on making them more healthy, making them more sustainable. So producing them with less energy or with green energy. And making them use less sort of water and other utilities in the production. But the production will go where the market demands. But I think the addiction point is probably somewhere where actually companies would actively avoid, because to me it sounds like it would be full of litigation, right?
Actually, you might want to stop sharing your screen.
Oh, sorry.
Yeah.
I don't know how to do that. I've actually, Zoom has gone very funny with me. I don't know if you can do that.
Let me see.
Ah, there we go. Oh, no.
Let me try.
It's auto minimize the toolbar and I can't see it. Oh, there it is. Okay, there, I found it now.
Fantastic. No, it hasn't quite worked. Hang on, I'll do it from my end.
There it says stop share. There you go.
Yeah, I've started to share this screen. That's okay. We could just leave it on there. How do I swap? There we go. Everyone could just see my screen now. So some more questions which have come up. Did you think your PhD improved the kind of jobs you could get and your salary range?
Not really. For me, my PhD improved me as a person, right? It gave me an opportunity to do a lot more things with my time at university.
Yeah.
But I came out at the top of the salary range for the graduate program, but I was with people who hadn't done a PhD. Right? But I encourage people to think of your career as a journey and a marathon and not a sprint. So from my point of view, yes, the PhD was an investment early on, but it taught me how to write very well, taught me various Excel and Word tricks, which I still use to this very day. And it let me expand my social extracurricular activities and my network and my friendship. You know, if I hadn't done my PhD, I'd never have met you. So those are the sorts of things that it lets you do. And I think right now, at this point, it's really starting to pay off. I think if I hadn't done my PhD, I would have had to maybe have pivoted and done an MBA. But I've been fortunate, I've been able to keep in the same direction the whole career without needing to do an MBA. But I think in the end, it's helped me go further. But for sure, it slows down the start.
I mean, there's another just follow-on question. What did you do during your PhD? What was your research on?
So my research was on complex fluids used in fracking in oil recovery. So when oil wells are a little bit too narrow, there's not enough gaps in the rock for the oil to flow out, they pump a fluid down at high pressure, which fractures the rock. And fluids, these particular ones, which were micellar, they flowed very differently under pressure, and they also contained little sand particles called propant to prop open the cracks once they were produced. It was a very interesting rheological problem, which actually I then did, and I didn't mention this, I then obviously chocolate is also a non-Newtonian fluid, as are Maynard's wine gums, particularly before they've set. And I actually even ended up sponsoring as a industrial supervisor a PhD on jelly babies. So I did use my PhD, but I don't use it anymore, I think it's fair to say. But I still use all the Excel tricks I learned doing it.
One question about biotechnology. I mean, the new chemical engineering course is chemical engineering and biotechnology. So there's a large element of biotechnology that we're going to be teaching in the undergraduate course. One of the students is asking, were you involved in any biotechnology at your work as a chemical engineer?
It's kind of been extraneous. So I've been sitting in the same office, particularly, well, brewing is biotechnology, right? There's a whole load of stuff around yeast there. We did a whole load of stuff around particularly creating energy and gases that we could then burn from our waste streams. So I was associated with people doing it who were chemical engineers, in fact, Cambridge chemical engineers, but I wasn't actually working on that myself.
But I mean, just generally speaking, there is huge scope in biotechnology as a chemical engineer where you could explore lots of industries. I mean, what we've seen with the pandemic, for example, with vaccine developments and how to manufacture vaccines on a large scale has been a problem that chemical engineers have been looking at and solving. So just a kind of general point, there is huge opportunities there for students to go on into those sorts of careers. Yeah. Another question. What do you think the scope of chemical engineering as a field? In what other sectors do you think a major in this can this degree be applied? So I think they're trying to say, how can this be applied in different sorts of career pathways?
Chemical engineering will take you everywhere, right? If you think of it, it's the way that you're taught to think about whole systems and processes. So you will find chemical engineers. There's a lot of us here at Amazon. There's all food and drink, pharmaceuticals, energy, sustainability, oil and gas, all the biotechnology companies. But a lot of people go into finance. You can go into patent law. You can go into to law. There's a whole load around medical devices as well as pharmaceuticals. That's chemical engineering. Everything in the world that is made needs a chemical engineer. Plus we're really good at other stuff like finance and law. So it's if you enjoy the chemical engineering degree, it won't limit you in the future.
Right. Couple of more questions here. One which says, I'm also from the Wilton area and I'm really interested in the Billingham plants. Are there any companies that you would recommend approaching there for work experience?
To be honest, I left that area when I was 16. Obviously, that was very recently, but what I would recommend is there's Google Maps, and also these companies change hands quite often. So Google Maps will help you find who's there. The other thing you can do is write to the Institution of Chemical Engineers and ask if they've got any contacts at companies in that area. And could put you in touch. So I would suggest those two approaches.
Yeah. There's a couple of questions here about A-level choices. One of the students has said that you did physics, chemistry, and maths, and whether it be okay if we were doing maths, chemistry, and biology as A-levels. I mean, feel free to drop into this, Rachel, but just to kind of answer that question, the essential subjects for chemical engineering, biotechnology is maths and chemistry A-level, plus another science is preferred. So if you're doing physics or biology A-level, that's absolutely fine. It's down to personal choice and preference and what you're interested in more. But in terms of what the requirements are to meet to be able to apply to chemical engineering and biotechnology at Cambridge, it's maths and chemistry which are the essential A-level subjects. Did you regret doing physics, Rachel?
No, there's a huge overlap between physics and the mechanics part of the maths A-level course. So I found biology actually involved a lot of learning of names and diagrams, whereas physics and maths were definitely more understanding of equations. And so for me, they were less work.
All right. Thank you very much, Rachel, for a very insightful talk, and thank you so much for your time with meeting these students and answering so many of these questions. Just to kind of wrap up the session, just wanted to really kind of put up a couple of slides just to remind people about the whole Davidson Inventors Challenge. Hopefully, all of you who've been involved in this program would have kind of taking away the message about chemical engineering and biotechnology as a discipline. It's all about designing processes. It's all about understanding how you can design processes, produce chemical and biochemical products. And these could be in a vast range of industries and applications. And it's all about understanding how these sorts of processes can be scaled up to produce chemical and biochemical products or commodities at large industrial scales. And that's what the whole discipline is all about. And if you're really interested in chemical engineering and biotechnology course at Cambridge, I mean, what I've tried to do is just put up a slide here, which kind of outlines sort of key kind of areas that you'll be learning about as part of an undergraduate course. So in the first year, the course is mainly focused around introducing you to more pure and applied sciences. And then in your second years, you'll be going on to learn about the fundamentals of chemical engineering and biotechnology. And in the third year, we focus mainly on the applications and design side of the course. And then in the fourth year, there's an opportunity for students to learn about advanced and broadening topics related to chemical engineering and biotechnology. I hope these interaction with us over the course of the last few months through the Davidson Inventors Challenge has been one which has been very useful and resourceful for you guys. And we really look forward to hearing from some of you when you apply to Cambridge, hopefully. But if you wanted more information about the course, there's lots of resources available on the university website. You can refer to the prospectus on the university website, or come and look on the department website, where there's lots more resources about the undergraduate course. As well as that, there is the University Open Days, which are taking place on the 6th and 7th of July. You know, if you can travel up to Cambridge, please do come and visit us at the department. And if there are any other questions you may have about the admissions process, you can contact us on admissions@ceb.cam.ac.uk. So without any further ado, just wanted to say thank you again for everybody.
There is one more question, Cam.
Yes?
There is one more question in the chat.
Oh, is there?
Yeah.
See that. Hang on a minute. Let's have a look. Now my Zoom's gone funny. I can't find it. There we go. Stop sharing.
How much of chemistry is in chemical engineering?
Ah, yes. So, Rachel, would you like to try and answer that? Would you remember about how much chemistry is involved?
Well, I'm going to give the wrong answer, because when I did it the first year, I did the first year of a chemistry degree. But then once I got to the department, there was very little.
So in terms of the new undergraduate course, the first year, there was a lot of chemistry. The students actually go along to the same course that the first year natural sciences students do in 1A chemistry. So there's a lot of fundamental chemistry you learn about in the first year, as well as maths. And then in the later years, you get to learn about how to apply your understanding of chemistry to looking at processes and designs. So there's still a fair bit of thermodynamics, which can be broadly classed as physical chemistry and kinetics, you know, things like this. Yeah, so in the first year, you will be learning a kind of whole broad spectrum of advanced chemistry. Okay, brilliant.
There is two more questions.
Oh, there's more. Okay,
Two
well,
more.
let's go. Many other universities have chemical engineering and biotechnology as separate courses. So how much of each of these topics are taught in the course at Cambridge? Well, the course at Cambridge, which we're going to be launching this year in October, is the first year we're going to be running it. The idea really is we've recognized the fact that, you know, process industry is not just looking at producing chemicals, but it's also looking at producing biochemical products. So the whole course is designed to try and teach you about how you can design processes for making chemical products as well as biochemical products. So there is an emphasis to both sides of the subject area on how we can broadly train undergraduate students to become sort of more rounded chemical engineers who have a broad understanding about process industries in various sectors.
And Cam, in the final year, we were able to choose what we studied. Is that still the case?
Yes. So in the final year, there's a whole set of broadening topics. So again, there will be a whole set of optional subjects, topics there that you can choose from, which would be very sort of advanced subjects from traditional chemical engineering through to computational fluid dynamics, through to biotechnology and the pharmaceutical industry. So the whole broad range of subject areas there that you can look to kind of study to specialize more in.
And I guess what I was trying to hint at was you can also avoid areas. So if you don't want to specialize in biotechnology, like I didn't, you can go and do computational fluid dynamics and rheology and things instead. So you do have more options in the final year.
There's lots of options there. Yeah. Last question here. Is maths a required higher level subject to study chemical engineering? I presume this person is studying the IB, International Baccalaureate course. So yes, if you are doing IB, then high level maths and high level chemistry are going to be essential. You should be doing both of those as part of your IB course. Great. I think we're now at the end of the questions. So once again, Rachel, thank you so much for your time and look forward to seeing you soon.
Well, yes. Thank you for inviting me.
Thank you, everybody. Good luck with your coming exams and your applications to universities to all the students. Thanks again for joining us. Bye.
Bye.